Okay, so in this video, we're going to address a very important issue, and we're going to start talking about this description of motion. This important issue of reference frames is it is important in physics because this is where we take our measurements from. Okay, so any measurement of position, distance, or speed must be made with respect to a reference frame or frame of reference. This, when we say respect to, what that really does is it just shows you where the measurement is taken from. So if it says with respect to the origin, so if I've got a number line and I've got my 0 point, that means like, and it says with respect to the origin, that means all my measurements are going to come from that position. Just real quick, here's a little bit of an example, or just kind of if I'm standing outside this train watching all this happen, I'm asking ultimately how fast is that person moving? Okay, so I have a reference frame here. He has a reference frame there. And so what that means is his speed is going to be different because of what he sees or what that person sees. Mine's going to be different because basically what I'm going to do if the train is moving 80 kilometers per hour and the person's moving 5 kilometers per hour, what I see, his speed with respect to me is going to be what the speed of the train is plus what they're moving. And so the passenger's speed with respect to me is 85 kilometers per hour. Now, for them, their speed is just going to be 5 kilometers per hour because that's in their reference frame. Now, in physics, what we're going to do is we're going to draw a set of coordinate axes to represent that reference frame. And coordinate axes is the same thing that you're seeing in math. The first real descriptor of motion that we talk about is position. And basically, the thing about it, it's the object at any moment is given, or the position of the object is given by its x coordinate. Okay. Now, what happens is in physics, we think the x coordinate that relates back to position, right? It could also be time. So if I have if I'm doing a position time graph, so if I'm doing a PT graph or XT graph, right? My origin is going to be x equals 0 meters, t equals 0 seconds. All right, and then the distance, right? So really, the first question we want to ask is how far does something travel? So the distance an object has traveled and its displacement, which is defined as change in position. Okay, um, and so those are the two things there to find distance. Right, add up all legs. Right, think about Google Maps. Okay, and then for displacement, the variable for displacement is delta x, and it's a change in position, right? So that's what that delta means. Okay, and so it's going to be our final position minus our initial position, right? And so what you see right here is kind of your first physics formula. Okay, now real quick, if I'm just doing some quick examples here, if the question says what is the distance traveled, this is only going the distance traveled is going to be 20 meters. Okay, but if I'm finding the displacement, I'm going to do delta x equals x minus xo. So my final position is 30. My initial position is 10. So I'm going to do 30 minus 10. And so my displacement is going to be a positive 20 meters. Okay, now what happens if I walk, excuse me, walk the other way? So again, my distance, my x, is going to be 20 meters, right? Because I'm traveling this really the same distance between these 2 points. But my displacement is going to change a little bit because again, I'm going to do final minus initial. But in this one, I'm going to do 10 minus 30, which is going to be negative 20. Okay, and so it's going to be negative 20 meters. So let's look at a quick example. And so we have an ant starting at 20 centimeters on a piece of graph paper and walks along the x-axis to x equals negative 20 centimeters. It then turns around and walks back to x equals 10 centimeters. Determine two things: the ant's displacement and the total distance traveled. So if you want to visualize this, um, here is my number line, right? So this is very similar to like if you're doing math, just learning how to add and subtract numbers. Okay, so they're going to walk, right? So the ant is going to start at 20 centimeters. Okay, he is going to walk to negative 20, and then he's going to walk back to positive 10 centimeters. Okay, so what's his distance traveled? Well, I'm going to go 40 centimeters that to the left, and then I'm going to come back 30 centimeters. So to find his distance, I'm just going to do 40 centimeters plus 30 centimeters, which is going to tell me that he walks a distance of 70 centimeters. Now, the displacement is very simple. My displacement is where I start, right, and where I end. It doesn't matter what I did in between, right? In fact, this part of the travel actually gets canceled out because I'm going left and then going back right. And so I'm going to do x minus xo, which tells me it's going to be 10 centimeters minus 20 centimeters. And so the ant's displacement is negative 10 centimeters. So just a couple things. If I know if I end to the right of where I started, I'm going to have a positive displacement. If I end to the left of where I started, I'm going to have a negative displacement. And you can see here in this case, my distance traveled was greater than my displacement because I turned around. So if at any point in time you turn around, they're no longer going to match. But there are times when they will equal each other, as if I move in a straight line, right? If I don't turn around at all. Okay, and then that's going to give me this. Then we're going to have the plus minus. Okay, or this is going to be a straight line. Um, so we're going to keep building on these descriptors of motion and move